Hi everyone. In this video, we are going to talk about logic, which is the foundation of all mathematical proofs. A lot of students feel that proofs are scary or confusing, and most of the time, it's not because the math is hard, it's because the logic isn't clear. So today, we'll slowly understand what logical statements are, how we combine them, and how to reason correctly. No tricks, no competition problems, just clean basics. Let's start with the most basic idea in logic, a proposition. A proposition is a sentence that is either true or false, but not both. So, proposition, a statement that has definite truth value, true or false. Examples help more than definitions. So, 2 is even is a true statement. 5 is a prime number is a true statement. 7 is negative is a false statement. All of these are propositions. Now look at this. X plus 1 is equals to 3 is 2 even and close the door. These are not propositions because first statement depends on the value of x. That is, when the value of x is 2, the statement is true. But in other cases, the statement is false, so it doesn't have a definite truth value. While the second statement is a question, and the third one is a command. Logic only deals with propositions. Now, moving further, let's look at some logical connectives. Not. It is the simplest connective, which is written as this. For example, consider a proposition P, 2 is even. Then it's the not P is 2 is not even. It is also known as negation. So if P is true, then not P is false and vice versa. Next is and, which is written as this. So here consider proposition P, which is 2 is even, and Q, which is 3 is prime. Then P and Q is 2 is even and 3 is prime. This is true only if both the statements P and Q are true. Now the next one causes confusion, which is or. P or Q means either P or Q or both. So in mathematics, or is inclusive. That means if P is true and Q is false, or if P is false and Q is true, or if both the statements are true, it will result in true. For example, I will have tea or coffee, or possibly both. Next is implication. It is the one that students struggle with. P implies Q means if P, then Q. For example, consider a proposition P. A number is divisible by 6, and another proposition Q. The number is divisible by 3. If P is true, Q must be true. So the statement is false only when P is true and Q is false. Otherwise, the implication is true. Now let's look at truth tables. Truth tables help us systematically check logical statements. This is a truth table for implication. So when both the statements are true, their implication is also true. But when the first statement is true and the second is false, then the implication is false because we know implication means if P, then Q. And if first is false, then no matter what is the truth value of the second proposition, the Implication is always true. Truth tables removes ambiguity. These are some common mistakes that students make. First is thinking that or means exactly one. Next is thinking that implication means cause. And last is forgetting the brackets in negations. These small mistakes cause big proof errors. Now, try these questions on your own. First is if P is false, what is the truth value of P implies Q? And second question is X is equals to 2 a proposition? Pause and think. So the first question, as we saw earlier, if the first proposition is false, then no matter the truth value of the second proposition, the implication always results true. And the second question is X is equals to 2 a proposition? Yes, X is equals to 2 is a proposition because here we are defining a specific value which is 2 to the variable X, so it doesn't change. So in conclusion, if logic makes sense, proofs will make sense. You don't need to be fast, you don't need to be an expert, you just need to be clear. In the next video, we'll see how logic is actually used in proofs. Thanks for watching.